The under pressure simulation is an interactive educational tool designed to help students understand the principles of pressure in fluids. This simulation allows students to explore how pressure changes under and above water as they vary fluid density, gravity, container shapes, and volume. By providing a visual representation of these concepts, the simulation offers a deeper understanding of the fundamental mechanisms behind fluid pressure. This simulation focuses on the behavior of fluids under different conditions. It illustrates how pressure changes with depth, fluid density, gravity, and the shape and volume of the container. The simulation displays a thin slice of an underground basin filled with fluid, where the top of the basin is at sea level. This setup allows students to observe the effects of pressure in a controlled and interactive environment. Key components of the simulation. 1. Fluid density. Students can adjust the density of the fluid in the basin. Changing the density affects the pressure at different depths, as denser fluids exert more pressure than less dense fluids. Number 2. Gravity. The simulation allows students to vary the gravitational force acting on the fluid. Changes in gravity affect the weight of the fluid column, which in turn affects the pressure at different depths. 3. Container shapes. Students can explore different container shapes to observe how the shape of the container affects the distribution of pressure within the fluid. 4. Volume. The volume of the fluid can be adjusted to observe how changes in volume affect the pressure. Increasing the volume of the fluid increases the depth and, consequently, the pressure at the bottom of the container. 5. Pressure indicator. The simulation includes a pressure indicator that visually represents the pressure at different depths within the fluid. This indicator helps students understand the relationship between depth, fluid density, gravity, and pressure. The under pressure simulation provides a hands-on approach to exploring the principles of fluid pressure. By adjusting the fluid density, gravity, container shapes, and volume, students can observe the following key concepts. 1. Effective depth. As the depth of the fluid increases, the pressure also increases. This is because the weight of the fluid column above a given point exerts pressure on that point. The simulation allows students to observe how pressure increases with depth in a visual and interactive way. 2. Effective fluid density. The density of the fluid affects the pressure at different depths. Denser fluids exert more pressure than less dense fluids because they have a greater weight per unit volume. Students can adjust the fluid density and observe the corresponding changes in pressure. The under pressure simulation offers several educational benefits. 1. Interactive learning. The simulation provides an interactive and engaging way to learn about fluid pressure. Students can actively participate in the learning process by adjusting the fluid density, gravity, container shapes, and volume and observing the effects on pressure. 2. Visualization of abstract concepts. Fluid pressure can be a challenging concept to understand. The simulation provides a visual and tangible representation of the principles of fluid pressure, making them more accessible and understandable. 3. Experimentation and exploration. Students can experiment with different fluid densities, gravitational forces, container shapes, and volumes, and observe the resulting changes in pressure. This exploratory approach encourages critical thinking and problem-solving skills. 4. Real-world application. The simulation provides a practical application of the principles of fluid pressure, which are fundamental to many real-world phenomena. This helps students see the relevance of these concepts in everyday life. 4. Data collection and analysis. The simulation introduces students to the process of data collection and analysis. By observing the pressure indicator and recording the changes in pressure, students can collect data and analyze the relationship between depth, fluid density, gravity, and pressure. The under pressure simulation is a valuable educational tool that brings the principles of fluid pressure to life through an interactive and engaging context. By allowing students to explore how pressure changes under and above water as they vary fluid density, gravity, container shapes, and volume, the simulation provides a hands-on learning experience that enhances understanding of this fundamental concept. This interactive approach not only makes learning more enjoyable, but also fosters critical thinking, problem-solving skills, and a deeper appreciation for the relevance of fluid pressure in the real world.